The cutoff frequency is a key parameter in filter design. It marks the boundary between the passband, where signals are transmitted with little attenuation, and the stop band, where signals are significantly reduced. In both RC and RL circuits, the cutoff frequency is defined as the frequency at which the output signal drops to 1 divided by square root of 2, which is approximately minus 3 decibels of the maximum value. Now let's have a look at the mathematical underpinnings of the cutoff frequency. For RC and RL circuits, the cutoff frequency can be derived from the filter's transfer function. Let's have a look at RC circuits first. In an RC filter, the cutoff frequency is given by this formula where Fc, the frequency for cutoff, equals to 1 divided by 2 times pi times R times C. You've seen this formula several times in the past in previous lectures. Again, R is the resistance and C is the capacitance. And the formula is derived by analyzing the transfer function, but I'm not going to get into this now because we've talked about it in previous lectures. For an RL filter, the cutoff frequency is defined by this formula. Fc equals to R divided by 2 times pi times L. I've also prepared a small table that summarizes the two formulas for the cutoff frequencies for RC and RL filters. I've also put together a small script that demonstrates how to calculate and plot the cutoff frequencies for both an RC and RL circuit. The script also shows a comparison by marking the cutoff frequency on frequency response plots. When you run this script, it produces two plots, one for the RC filter and one for the RL filter, and each plot displays the cutoff frequency as a red dashed vertical line. Let's look at the key takeaways from this lecture now. The cutoff frequency is the point where the filter's output falls to 1 divided by square root of 2 of the maximum that defines the boundary between the passband and stopband. In RC filters, the formula that we use to calculate the cutoff frequency is this. And for RL filters, the formula is this.